Here's a physics problem that asks you to solve for velocity from a position graph. So you could use your equation, velocities change in position over time, but I'd like to practice a little bit of a different method. I'd like to use this concept that velocity is the slope of a position graph. And that's what we're going to do in this problem. We're going to look for velocity by finding the slope of a position graph. So let's see what this problem is asking in specific. This problem says, a position time graph for a car is shown below. That's right here. Determine the car's velocity at 2 seconds. So I'm asked to find a velocity from a position graph, and when I'm asked to find anything from a graph, the first thing I do is look at the axes, see if I know what's on them. So on my y-axis right here it says position in meters, and in my x-axis right here it says time in seconds. So I want to find the velocity at 2 seconds. And notice that this graph goes on the position 0, 2, 4, 6, 8, 10, and on the time axis 0, 1, 2, 3, 4. So I want to find the velocity right here at 2 seconds. I want to find the velocity right at this moment. So I want to know the slope right at this moment. But to find the slope right at this moment, I can look at this graph and say, oh, it's a straight line. It has the same slope the whole time. In other words, this car has a constant velocity the whole time. So to find the velocity, I'm going to look for the slope of this graph. And to find the slope, I need to know the first and last coordinates of my line. Or really any coordinates will do, but the first and last are pretty obvious on this graph. So the first coordinate, notice that the x coordinate is 0, the time to start is 0, and the y coordinate is 10. The position to start is 10 meters. I also really clearly can see this point, so I'll take a look at that coordinate as well. The x coordinate is 4, the time is 4. The y coordinate is 2, the ending position is 2. And again, I'm looking for the slope of this line. That'll be the velocity, simply because we're looking at a position graph. So slope is rise over run, or if you will, the change in y over the change in x. How much does the y value change divided by how much does the x value change? So I'm going to do the change in y over the change in x. Change in y, that's just y2 minus y1. Change in x, that's just x2 minus x1. So this is pretty simple since I already know here's my first x, here's my first y, here's my second x, here's my second y. So let's start with y2. y2 we said is 2. y1 is 10. So I'm going to sub those in for y2 and y1. And let's look at x2 and x1. x2 is, oh, there's my x, 4. And x1 is 0. 4 minus 0. So in my numerator, I'm going to get negative 8. In my denominator, I'm going to get 4. Negative 8 over 4, that's negative 2 meters per second. And in physics, it's perfectly fine to end up with a velocity that's negative. It just means my position graph points down. So this has a velocity of negative 2 meters per second.